Okay. Do you hear me, guys? Okay. Okay. Yep.
Okay, welcome to the next session. I would like to just repeat the information about the lightning talks. Again, there are lightning talks scheduled at 5:30, and you can propose your lightning talks that you would like to give. It's 10 minutes talk. You can write your topic upstairs on the whiteboard. You can also vote for the lightning talks that you would like to see. And now we are ready to start next session. Tadeáš Kříž.
Okay. Oh, sorry. The RoboElectric is basically a Chain 4 runner, and it allows you to run Android code, and it does so by mocking most of Android APIs in Java virtual machine. You don't need to run on Android when you use the RoboElectric. So that's very nice. It mocks almost most of Android APIs. It has amazing performance. It basically, the bottleneck there is on the first run of the test, and that's downloading the mock library from Maven, I believe. But after that, it just runs like any other JUnit tests. The downside is that some APIs are missing. It won't cause an exception when you call them, like it would if you use the Android.jar. But the problem is that, for example, bitmaps are not implemented. So if you need to test some bitmap modification, it just won't work. It will be always returning empty arrays for any bitmap, and you won't be able to work with that. So that's one downside. But they increase the cover of the mocks very quickly. And for example, half a year ago, there was no support for SQLite testing. Now there is. So again, download link. Okay, let's go to iOS. iOS for me is worse to test. Each of new release of iOS and Xcode basically breaks everything apart. Those tools stop working, needs updating, and so on. It also is not open source. The tools are not open source. Everything is basically reverse engineered, and that's basically a problem with testing tools and having stable testing tools through the development cycle. So the first is that if you want to write functional tests, by default there's the UI automation, which runs functional tests written in JavaScript. Some of you might like JavaScript. I'm not a JavaScript fan, and I want the code that is testing the application written in something like Java or Objective-C or Swift. So there's a possibility to do that with KIF. You can write tests in the Objective-C and Swift, and basically the Objective-C works like any other unit test on iOS. The Swift tests are a bit more struggling to get them working at first, but it's all documented well on KIF site. It's great that when you use the KIF, you have all the code in one code base, so you can even share some code between the tests and the tested software if you wish, but I don't recommend that. And also it runs from the Xcode itself, and it's faster than the JavaScript. And it's really easy to install using Cocoa Pods, which is the dependency management on iOS. And you can also install it by yourself, but the Cocoa Pods solution is very easy to do. Support for iOS 5.1 and above. It works well with 8.1 and 8.0. They state on the KIF side that it should work with even lower than 5.1, but I haven't tried that because if you need that, you probably need old Xcode, old images, and old OS X because the incompatibilities. Another very great thing about the KIF is that it's under active development. So with each new Xcode version, each new iOS version, they update it to work with that version, and also they are adding more features, fixing bugs, and so on. I wanted to show you another software which is like KIF. It's called Subliminal. The problem is that it seems that there was no updates for a year or so. it was superior to KIF, but it seems that the authors didn't want to update it anymore. Downsides, as I said before, the KIF might break with each new Xcode or iOS version. That's not a problem that anyone would be able to solve, because it basically is on Apple, that they don't provide any open source build tools. All the tools needs to be reverse engineered. So that's a problem, and you would need to wait, let's say, a month before new KIF version would be released, which would have the test fixed for the new Xcode and iOS version. Okay, again, Arquillian integration. Arquillian Osmium is a new library written by me, and it's basically very similar to Droidium, but it's younger. It's not the feature parity is low, and I will talk about that later. Yeah, you can write functional tests for iOS in Java. You can integrate it with other testing, like if you need other libraries, everything in Java, you can all use that, which you wouldn't be able to do with the KIF in Objective-C. Sorry, it is Arquillian container. So again, like with the Droidium, you get the deployments. You can deploy on the device. It will give you the WebDriver, again, using the Arquillian drone. You can inject it into your test class and then use it to test the application as you would be testing the Android version or a website. Great thing about those tools, we are working to get them working all together, so you would be able to test simultaneously a web service, JavaScript web application, iOS application, and Android application, or many variants of the applications. And we are really trying to have these compatible so you can use them at once. And Osmium also comes with API for building the application from sources. On iOS, we believe that there might be you might not have the build it app for your application, because on iOS the location where it's saved is mostly generated, and finding the application package might not be easy. So we come with the building solution. You basically point it to the source. You point it to some certificates for which are required by the iOS build tools, and it will build the application and deploy it on the device. As I said, it's a very young extension, and it has many flaws. First, it's just alpha with basic functionality. It's not well tested. We are basically starting to use it in our suite, but there are not much functionality as of now. It's not yet in Maven Central. It depends on iOS driver library, which in its latest version is not released on Maven Central yet, and we are waiting for it to be released, because with the older version, as I said, new Xcode version breaks everything, and it wasn't working with the new one. The simulator is not yet supported, so that might be a huge problem. You might not have the device to run on, so as of now, you cannot run on the simulator. There's planned support for Arquillian, which is very used library on iOS, and that would also enable to test the using the tapster on using the Osmium. Okay, now we get to the fun part, which is the tapster. Tapster is open source robot you see there. It's licensed under BSD. Its great feature is that it's clicking on the device like your real user would be. So there is no thing like hiding controls behind another UI view, and you can be sure that if the robot can touch it, the user can touch it. It has JavaScript interface. It's using the Johnny 5, I believe, library, which is used with the I just forgot the name, sorry. But it basically communicates with the Arduino, that's it, using a serial bus, and you can communicate with it using the JavaScript. It has nice APIs for many boards. Here you can see the server board, which is needed to for easy support for the servers here. And it's super cool. As you will see, it's really nice, and it's just working like a charm. Well, almost. Problem is that it's right now it's supported only by Appium for iOS, and it doesn't really work that well. It's not precise enough, and so on. There's almost no documentation. I'm not sure how Adam, who built it, did it, but I didn't find any documentation, and basically you are running blind and don't know what to do, how to set it up correctly, and so on. Calibration is painful. The calibration is so difficult. This is not yet calibrated, and we have it for 3 days or so. I've been trying to calibrate it to show you a real example with real tests. Not happening today, guys. And it lacks precision. At least in our version, the precision is a problem, but it might be because of the missing calibration. So that might be a valid point or not. Depends on the future. So let's get to the demo. Okay. So here I have JavaScript console open up to control the robot. Basically, you can call command go, which will move the arm. So if I say go 0, 10, minus, it moved. I will do a bit this. Okay. Now you can hopefully a bit see the device on the camera too as well. So it just there is one command which is just dance, and does this just to test the motors that are running. And I've added a few commands. One of them is the reset, which just sets it to default position. Then there's phone calibration, which is for me to set the phone correctly to be able to show you the next part. And it just points to one spot when where I need to put the home button of the iPhone. And then I call reset again. And we can try if it wants to play some Angry Birds. And it has a really nice thing, and that's play forever. And basically now it should play forever. So it never gets bored with Angry Birds, which is strange because I did pretty quickly. I will now tell you about how it works now. It basically is now hard-coded, and it has hard-coded all the positions where it needs to be. And it took me a while, about, I don't know, 2 hours to set it correctly. Then I moved the phone and forgot to do the phone calibration, and I needed to spend another 2 hours to reset the positions. So that's about a painful calibration. As you can see now, it didn't work because of some timing issue, and now it won't play forever. So I need to reset it manually. And when I do that, it will play again. As I said, there is a JavaScript scripting, so you can very easily. Yeah, it just got out of sync, probably moved. I don't know. Never mind. I will stop it. Yeah, it should just. Okay, just stop. Basically, there is the application from Appium, and it's for calibration. For me, it didn't work at all. It should try to calibrate the arm to see in which height the arm is, and using the Appium, it gathers the coordinates on the screen. But this part worked. The calibration file was created, but when I used it with the Appium server to run a test, it just was clicking basically almost randomly. The calibration seems to have some issues there. Let me show you. Okay, let me show you how you can write your own stuff into the the console. Let's say the console. It's basically just you can either edit the JavaScript file, which I did here. And I'll open with it. Let's say text edit. Let's see. Okay, that might work. As I said, you need the Johnny 5. Then there's the file IK, which is kinematics for the arm. It's hard coded. There are some constants hard coded. I'm not sure if they say that those constants are specific to each tapster, so it might be a way to calibrate it to find the right constants. Anyway, there's the board creation. Then you set up the servos. You set up on which pin they are and the range. Some error reporting. The REPL is the console you've seen. I've written the commands before. And with this, you can add some variables into the console. So if we wanted to see the servo 1, you can see that there are some information about the servo. It's just basically a JavaScript object. You can control the servers yourself, but there are there's a go, and then there are more functions in the kinematic JavaScript file. So this is the dense method. You can see it just randomly picks a position and then moves to it. And there's the injection of the commands into the repo. I've also this is the method I used for playing the Angry Birds. As I said, all those numbers you see there are hard-coded, and if I move the phone even a little, they won't work. Hopefully, I'll be able to sort that and to make it work with Appium and possibly the Osmium to run automated tests on the Tapster. And I would like to show you very simple two very simple methods. Basically, there's the circle. When I call the circle with the 3 parameters, the radius would be the radius of the circle. Stops is how many points will be used for approximation of the circle, and there's the step time, which means how long would each the approximation step should take. And then there's the next circle step, which just goes through the approximation points and calls the next and the next and the next. And the output here is like this. If I remember correctly, it was like 20. Okay, let's hope it won't break. Okay, it broke. Yeah, there might be problem with that. And now it just moves in circles. And you can program it to do anything you want. This might work well if I wanted to make a soup. I tried to use a pencil instead of the touch, let's say, pen. It didn't work well because of the arm position. If you probably can't see it properly, but it moves slightly up and down during the circle. So it was like half a circle with the pen. It might work better with a marker, but I didn't have one on me, so didn't have a way to try that. If you guys are interested, I stop it first. Okay. How much time? 10 minutes? Okay, thanks. I'd like to talk about the hardware itself. As I said, there's the Arduino board, and on top of it is a motor shield. It has 3 servos connected to it, and this kind of combination is called Delta robot. It's not easy to operate. It would be easier if it has a way to move up and down on these pillars. It has the touch screen pen. It's not easy to make, as it would be like just connecting, putting there a touchscreen pen. It doesn't work because you need to discharge capacitance on the screen, or at least that's what I understand from the manual. And you need to connect it to the ground. And that's what I did. I used it's called some kind of foam. It's used for packaging microchips, and it's conductive. It's probably conductive foam. And I've put it there and connected it to the ground, so it discharged the capacitance or something like that. Then there, we used our 3D printer in Red Hat. Well, Adam did, and there are some printed parts connected with magnets that gives it, I think it's 4 degrees of freedom, if I believe correct. If I'm correct. Okay. That would be all about the hardware. And think I was talking a bit fast. Okay, any questions, guys? Okay. So that would be all. Thank you very much, and sorry for shorter presentation. And I would like to you to go on that link and give feedback on the presentation. Thank you.
Okay, we will take another break, and the next presentation will start at 11:30.